In this video, we're going to go through on the Anglo-Chinese School Junior Weighted Assessment 2 2024 Primary 5 Mathematics. So let's get started on the first question. So the first question is AB is the base of the shaded triangle ABF. So if AB as the base of the shaded triangle ABF, find its height. Okay, so to just recap, we have usually three different types of triangle. So you have this kind of triangle, right? So this triangle usually has the base and the height over here. Another triangle is a right angle triangle. So this one is the base and this is the height. Okay, height, and this is the perpendicular. The last one, which is the a bit odd one, is this and this. Okay, and this is where you have your base. Okay, this is a bit chart, but you have this, and this, and this is your right angle over here. So this is your base and this is your height. Okay, so in this case, this triangle over here is this type of triangle because our base is over here. Okay, so if I were to, for example, just essentially just draw this triangle, that's what you see over here. Okay, then if I were to just like, you know, s- move this, okay, and then just make it so that I can twist it or just turn it, it looks something like this, right? Okay, so this triangle is the third type, which means that we have a dot, 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 which is the perpendicular triangle over here. So now if you were to move back this triangle to its original place, which is over here, then what we can see over here is that it is very, yeah, it is exactly what we have shown or gone through in this case over here. So that means the height is here. This is the height. Okay. And this height is, where can we find this height? Right? So if you were to look closely, this height is actually the same as this height over here, which is B and E. So the answer is B and E. B and E. So number 2. All right, so let's move on to the next question. Question 2. What is the volume of the cuboid that has a square base of side 4 cm and height 10 cm? So this is the flat version of the square. That's what you see over here. One side of it is 4 cm. What is the property of a square? All right, a square has what sides? Has equal sides. Okay, what do you mean by equal sides? That means this side is 4 cm, this side is 4 cm, and this side is 4 cm. So in this volume over here, we know one side is 4 cm. That means this side over here is also 4 cm. So to grade the volume, we usually need to have the height, which is h over here. So height times length, L, times breadth. So height times length times breadth, or length times breadth times height. So h over here is 10, length is 4, and breadth is 4. So if you were to calculate, so easier is to just have 10 as is, and then we just calculate the 4 times 4, which is 16. And since 10 times 16 is 160 centimeter cube. So the answer is number 3, 160 centimeter cube. Let's move on to the next question. So this is a ratio question. You can think of it as a pattern question as well. So we have 9 is to 5. What is to 55? So in this case, 5 over here, what multiplies to what multiplies 5 to become 55? If you don't know, then don't worry. So we can always reverse engineer. So what time or divide, not times, but divide to 5, right? So what divides 55 to 5? So the answer is 11. So if you were to reverse it, okay, which is multiply, that means we multiply 5 by 11 to make it 55. That means we do the same with number 9. So with 9, we multiply by 11. This is 99. So the answer is number 4 over here. All right. Because ratio always stay the same when you change its numbers. Okay, let's move on. All right. So question number 4. So the two solids below are made up of identical unit cubes, solid A and solid B. How many unit cubes need to be removed from solid A? So usually what I like to do is to cut this in the middle over here and over here as well. So it's easier for us to count. So we have our left side, so left, and then we also have our right side as well. So this is solid A and solid B will be the same left side and also the right side. Okay, so let's go for the solid A right side. Okay, so this is 1, 2, 3, 4, 5, and 6. So that is the right side. For solid B, we're gonna count as well. 1, 2, and 3. Okay, so let's move on. So we're gonna calculate the left side for solid A. So this is a little bit like something that you need to be aware of. Okay, so if you were to look at this, okay, the height of this uh, left side of solid A, so the height is 1, 2, 3, and 4. So, and then there's also 1, 2, 3, 4, 5, and 6. So this is 6 over here. So I will just put this thing over here as 6, right? This is 6. But we are also left with this whole line. So if I were to draw this out, actually we are left with one whole row of cubes that is hiding in here. And this is 4. So this whole thing is 4. This whole length over here is 4. So that means the total is 4. I'm just going to write down 6 plus 4 plus 6. This will be 6 plus 4 is 10, plus 6 is 16. So now we move on to the left side. So this is 1, 2, 3, and 4. Then we have the height 1, 2, and 3. So this first here, we can say this is 4. So this whole block over here is 4. Then we are left with the last one, the middle part. So this over here has 3 blocks in this case, right? So I'm going to put here as 3. So if you were to add everything, so it's 3 plus 4 plus 3. This is 10. So how many cubes do I need to remove from solid A to form solid B? It's basically 16 minus 10, which is 6. And the answer is number 2, 6. All right, let's move on to the next question. Question number 5. Over here, Sully and Mike had a total of $92. Sully had $36. What is the ratio of the amount of money Sully had to the amount of money Mike had? So, Sully, we know Sully is $36. And then Sully plus Mike is equal to $92. So then how do you know Mike's, which is basically we minus off Sally. So Mike is equal to $92 minus Sally, which is equal to $92. Oops. Let me just put here. So $92 minus $36. Right? So if you do your workings, this should give you $56. Right? So now we know Mike's is $56. What is the ratio? So Sally first and then Mike. Okay, so we have Sally and then we have Mike. So Sally is $36. Right, so we put here 36. And then Mike has $56. So I'm gonna put here dollars 56. So what is their common multiple? So 36, if so you can just see over here 9. So that means there's a hint over here 36. If you were to divide into something, it becomes 9 as a ratio. So it should be 4, right? So if this can be divided by 4, that means this can be divided by 4 as well, right? So usually you can just like have your common multiple first. This is also 4. So 56 divided by 4 is actually 14. There you go. The answer is 9 over 14. So usually you can get the answer pretty quickly from the multiple choice that you see over here. So the answer is 9, 14. So the answer is 2. Okay, so 9, 14. Very good. Let's move on to the next question. Question 6. All right, find the area of the triangle P, Q, and R. So if you remember, we have three types of triangles. This is a right angle triangle because we have this, what do you call this, perpendicular box, I call it, inside the triangle. So that means without the dotted line. So that means how do we calculate the base? I mean what's the base? The base is over here and the height is over here. Okay. So in this case, if I were to just draw the triangle like this, okay, and then basically have this over here. Let me just draw it a little bit nicer. Okay, so because if you were to be able to like do what I do over here, I think this is very helpful. But in this case over here, we have to turn it to have a better understanding. So you see that it looks something like this, right? And that's where the base is at the bottom and the height is on the right side. Okay, so now if I were to move everything back to its place, okay, so I'm gonna make and resize this, and then this is how it looks like. Okay, almost there, and there you go. So you can see that the base, if I were to also move this, right, the base is this QR over here, and the height, yeah, let me also move this, the height is also here. Okay, so the base and height is here, and usually what I tell is to, when you see this perpendicular line, the lines that is connected to the perpendicular line is the height and base. So what you need to do is you just have half times what's the base, 6 times what's the height, 8. And then you can just divide. So 6 divided by 2, this is 3. So 3 times 8, which is 24. So the answer is 24 centimeter square. Let's move on. A box contains 32 red balls, 12 blue balls, and 16 yellow balls. Find the ratio of the number of red balls to the number of blue balls and to the number of yellow balls, right? So let's do that. So we have red balls to the blue balls to the yellow balls. Okay, so what we need to do is we need to put the red balls, which is 32, to 12 to 16, according to the question. So, what is the common factor between them? So, all of them can be divided by, guessed it, 4. So, this should be 8 to 12 divided by 4 should be 3, and 16 divided by 4 should be 4. So, the answer is 8, 3, 4. There you go. So, this is, yeah, I mean, the last one it says simplest form. So we are making this into the simplest form by dividing by the smallest common multiple, which is 4. Common factor. Right. Let's move on. So over here, Felicia stacked 10 cubes and glued them together to form the solid below. Draw the top view of the solid on the square grid. Okay. So what we can do is that, so this is something that we need to be in a way understand how it looks like. So usually when you have something like stacked like this, you technically can kind of ignore. So what I tend to do is to just have it look like this. Okay, so you can use, I recommend you to use your highlighter or pen or pencil. So I can just draw this, draw this, draw this, and draw this. Okay, and this is how it looks like. So if I were to take this out, it will look something like this. Okay, but the thing is that this is diagonal, right? Diagonal means that this is drawing like this, but the diagram below is square, so it's drawing like this. Okay, so what we need to do is to, in a way, we need to make sure that this thing over here, we need to in a way twist it lah, to something like this. Okay, so essentially it will become like this: go straight, turn right, go straight, and then turn left. Okay, so you need to know how many also. So this part over here, I would say this part is 2. Then this part over here is 3. This part is 3 squares. And the last one is 2 squares. Okay, right. So you have a rough idea on how to draw this. So we can go down. And then what we can do is to just draw it. So I'm going to just use the highlighter. So you see over here. And then just going to draw 2. And then turn right to 3. And then draw straight to 3, and then draw 2 to the left. And there you go. That's the answer. Okay. So you just need to make sure you measure all of the boxes over here. Okay. Right. So now let's move on to the next question. Question 9. Okay. So question 9 says Charlie glued together 11 unit cubes to form the solid below. How many more unit cube does Charlie need to form the smallest possible cube? So cube, for to just recap, is basically, number one is it's a square, but also has the other side as well. Okay, so in this case, it will look something like this. So the property of a cube is basically, for example, if this takes, for example, 3 cubes, this will take 3 cubes length, and the height also takes 3 cubes length as well. So the thing is that if you were to just calculate how many in the diagram is one of the length, so you have the height over here, which is, so the height is 3 cubes. Now we just need to know what's the breadth over here. Okay, so the breadth is also 3 cubes, and the length over here is 1, 2, and 3, which is 3 cubes. So that means if you want to get, in a way, the volume, right, is basically 3 times 3 times 3, which is 27 cubes. right? So since we have 11 cubes, so we have to minus 27 minus 11, and we just need 16 more cubes. There you go. 16 more cubes. All right, so that is the smallest cube that we can get, and that's how we get 16. Next question, question 10. In the figure below, ABCD is a rectangle. AB is 15 centimeters. So this side is 15 centimeters. And BC is 10 centimeters over here. So the dotted line EF is parallel to AD. So this dotted line over here is parallel to AD. So it's another rectangle. Okay. So what is the area of the shaded part? Okay. So one thing you need to know is that any triangle, okay, any triangle that is inside a rectangle or even a square, whatever it is, basically, if it's the triangle, right, it is always half base, right? This is the base times height. So we know the area of a triangle is always half times base times height. Okay. So what if, for example, okay, the shaded area, what do you think the area is for the shaded area? If your answer is shaded is equal to what do you call this, rectangle minus the area of the triangle, and since the area of the rectangle is base times height, that means this rectangle or square, the shaded area is always half times base times height. Okay, so you need to know this concept, right? So once you kind of know this concept, generally, in a way, right, we know that this A, D, F, E, the shaded area is half of the rectangle in this case. And then E, F, G, A, F, C, B is also half. So in a way, right, this whole rectangle, the area is generally just half. Because since this is half shaded and this is half shaded, generally this whole thing is half shaded. So the answer to this is basically half times base times height, right? And essentially, it doesn't matter how many rectangles or uh, triangles inside it, since it's just one side times one side, it's basically that half times 10 times 15. And this is basically you divide 2 with 10, 5. So 5 times 15, 75. So the answer for this question is 75 cm square. Yep. So that's it. So always remember that anything inside any triangle inside the rectangle is always half the area of the rectangle or even square. So if you want to get a shaded area, it's the same because it's half, right? So this is why this whole thing, since there's two triangles, it doesn't matter how many triangles you have, it's always half. All right? So that's the answer for question 10. Let's move on to question 11. So question 11 says Josh, Amir, and Gopal shared a total of 480 stickers in the ratio of 3 to 4 to 5. How many more stickers does Gopal have than Josh? Okay, so basically, we need to get the total number of units. So total units, it's equal to 3 plus 4 plus 5. So this is equal to 12. Okay, so 1 unit is equal to okay, so total units is equal to 480 as well, right? So total units, we have 12 units is equal to 480. So 1 unit is equal to 480 divided by 12. And the answer is 4T. So now we know 1 unit, how many stickers there are. Now we need to know this statement over here. How many more stickers does Gopal have than Josh? So what we need to do is we need to know what's the basically difference, right? So let's put here Josh, right? Amir and Gopal. Okay. So we have the dot dot here. So it's 3 dot dot 4 dot dot 5. So we only care about, in this case, Gopal and Josh. Gopal and Josh. So then it's pretty simple. So how many more stickers? So we have many more stickers. It's basically 5 units or U minus 3 units. Okay, because this is Gopal, this is Josh. So 5U minus 3 units, this become 2 units, which is basically times 40 over here. This will become 80. So that's how many stickers Gopal have then more than Josh. So it is 80. So the answer is 80. There we go. All right, let's move on to the next question. Over here in the question 12, in the figure below, ABCD is a rectangle. The ratio of the area of the triangle CED to the area of the triangle CFD is 3 to 5. Okay, so CED, let's make it highlighted a bit, right? So this, and this, right? This is a bit too big, so I'm going to make it smaller. This, and this. Okay, so what's this? CED. Oops. Okay, so C, E, and D. Okay, so CED, and then we have CFD as well. So CFD, so I'm gonna put here C, F, and then D. Right, this one. Okay, so CED over here has 5, while CED has 3. Okay, so let me have a different color. 3, the area. Okay, so the area of the triangle of CFD is 350. Find the area of CED. Okay, pretty straightforward. So CFD to CED. So CFD is 5, CED is 3. So that means CFD is 5 units is equal to 350 centimeter square. So 1 unit is equal to 350 divided by 5, which is 70. Then we want to get CED, so that's why we have 3 units, right? So this is equal to 70 times 3, which is 210 centimeters square. All right, so let's move on to the next part. So question B, find the total area of the shaded part. So you can see here that we need to get the shaded part, which is this one and this one as well. So how do we get the shaded part? Basically, what we need to do is we need to get this triangle over here, and then we need to get half of the rectangle minus this triangle so that we can get this and this. Okay, so the thing is that if you remember that any triangle in a rectangle or square, no matter how it looks like, if both of the ends are at the end over here, they are basically, it's just half times base times height. And we already know half of the area. The half of the area is, in this case, CFD. So CFD is actually the area of half of the rectangle, which is 350 centimeter square. Okay, so that is one side of the solution that we know. Then now we see that in this case, if we know that this CED over here is 3 units, and this whole CFD is 5 units, how much is this triangle? You guessed it, it's actually 2 units. So what we need to do is to get the area of this of 2 units. So in this case, this triangle FED is equal to 2 units. So you type here, triangle FED is equal to 2 units, which is equal to 70 times 2, which is 140 centimeter square. So now the next thing is we need to know what's the half of the rectangle. So I would say area of half rectangle is equal to, thing is, it's actually 350 centimeter square. So put here 350 centimeter square. So now we know what to get the shaded area. It's basically 350 minus 140, which is 210 centimeter square. So the answer is 210 centimeter square. There you go. Right. And let's move on to the last question. Question 13. Wow, looks so complicated. Don't worry. Don't worry. That means it's very good. Okay. So let's go to this question. Last question, question 13. In the figure, ACGF is a square. So this is a square, okay? And then DEGF, sorry, is a rectangle. So CD is equal to EF. So CD, same length as EF. And then BC is 5 meters. And DJ is 3 meters. Find the area of the shaded part over here. Okay, so let's do it. Okay, so first thing first is that we need to make sure understand all of the different sides. All right, so since we know that CD over here is the same height as EF, that means this is just half, right? So basically, CD or equal to EF is equal to 12 meters divided by 2, which is basically 6 meters. So we have 6 meters over here and 6 meters over here. So the next thing is that we also know another side of the square. So ACHG is basically a square. So the property of a square is that all sides are the same. So we know that this is 12 meters. So HG is 12 meters. So what is GF over here? So since we know the length of this whole figure, so what we can do is that we can say GF is equal to 26 minus 12 to get 14 meters. Okay, because we have the whole length minus 12 meters, we get the remainder, which is 14 meters over here. This is 14 meters. Okay, so there is still more. Then we also know AB. Since this is 12 meters and this is 5 meters, then we can just get the remaining length. So AB is equal to basically 12 minus 5, which is equal to 7. So this is 7 meters. All right, last one is that since we know over here that this here is 6 meters, so this is also 6 meters, and we know this is 3 meters. So that means we can get this remaining height. So this is JG. So let's go down a little bit. So JG is equal to 6 minus 3, which is basically 3 meters. Okay, so we know this is also 3 meters in that sense. All right, so now we know almost all of the sides that we need to do. The next part is to just get the whole. Let's do one by one first, right? Let's do the easier one. Let's do the rectangle. So basically, we just need to get the area of the rectangle minus the triangle over here. So let's do that first. So shaded rectangle is equal to basically 14 times 6. That's what we see over here. So 14 times 6. So minus the triangle. So 14 meters times 3 meters times half, right? So shaded rectangle 46. And then we minus half times, in this case, 3 times 14. Okay. So we can cancel 2 with 14. This will be 7. So 40 times 6 is 84. Minus 7 times 3 is 21. And this is equal to 63 meters square. So now we know the shaded rectangle over here. So let me move this whole thing so that at least we can see over here. Okay. So let me just put it like that. Okay. This is over here. But yeah. So let's do this. Okay, great. So you have the shaded rectangle. That's what we see over here. Okay. Oops. Shaded rectangle. Okay. So now we have the shaded rectangle. I'm going to put a line across. Okay. Now we want to get a shaded square. So shaded square is equal to, so we just multiply the sides, 12 meters times 12 minus, so we have two things or two rectangles we want to minus off. Number one is this, so half times 12 times 3, so half times 12 times 3 minus half, so we have another one, in this case half times 12 times 7, so half times 12 times 7. So we already kind of, so let's do 144. So 12 times 12 is 144 minus. So half times 12 times 3. So 2 and 12, this will be 6. This is 18. Then minus half with 12, this is 6. 6 times 7 is 42. Okay. So now let's combine them. So if you were to calculate 18 and 42 is 60. So 144 minus 60 is 84. So we're going to have 84 meters square. So now the shaded area. So the shaded area is equal to 63 plus 84, which is equal to 147 meters square. And that's the answer. 147 meters square. And there you go. That is the whole of the ACS Junior with the assessment 2 for Primary 5 Maths. And that's about it.